Okay, so in this one, it's really tempting to say, oh, well, it's already factored. But remember, knowing that the product of b and 6b minus 13 equals -6 doesn't really narrow anything down. There's infinitely many ways to multiply two numbers and get -6. You could do -1 times 6, you could do 6 times -1, you could do -2 times 3, you could do -3 times 2. You could do -1/6 times 36. You can do this, like, go on and on and on. Any number you come up with, there's something you can multiply it by to get -6. So the key thing is getting a 0 over there, which means we're actually going to have to undo what at first might have looked like good stuff. We're going to distribute that b back in, get rid of the parentheses. And that actually doesn't have to be your first step if you don't want it to. I guess I'm thinking ahead a little bit. I am going to add this 6 to both sides. So what I'm thinking is by the time I get it over here, having that other stuff in parentheses is actually keeping me from being able to fully factor. It would make it like partially factored if I had that b removed from the 6b squared minus 13b. So multiply it all out, set it equal to 0, and now we can go for factoring. This in fact looks like a little bit of a tricky one. I don't have a greatest common factor. I'd really love to take that 6 out, but 13 is not divisible by 6. So I am just going to have to go for it. And it is a little tricky in that 6 has quite a few options. We can do 1 and 6, 6 and 1, 2 and 3, 3 and 2, and then we can throw negatives in the mix. I'm thinking though, if we just want -13 in the middle, that's not very big in comparison to 6's. So I'm thinking we'll want to choose the two factors that are closest together. So 2 and 3. And then I'm thinking I want to do the same thing here. So either 2 and 3 or 3 and 2. So you can just kind of think about your outside, inside. If I do the top pair, I'm going to get outside is 6, inside is 6, outside is 6b, inside is 6b, which does not add up to 13 or -13. So if I instead try the 2 and 3 in the opposite order, my outside is 4 and my inside is 9. And that actually does add up to 13, so that's looking good to me. So if I say 3 and 2, let me erase all this jazz that I scribbled down. So again, there's 4b, there's 9b, that adds up to 13b, but I actually want -13b, so I'm going to make them both negative. And then you can recheck again, make sure you didn't mess up. When I multiply those first two together, I still get 6b squared. When I multiply the last two together, I still get +6. So I think I'm in good shape. If you're in any doubt, FOIL it out and check. So now that I have a product, the big operation here is multiplication, equal to 0, I can conclude that the only way to make that true is to make one of the factors 0. That's what's special about the zero product property, is that you can't multiply two numbers and get 0 unless one of them is 0. Not possible. So in this first one, I'm going to add 3 to both sides, and then I'm going to divide both sides by 2. And there is one possible solution to this equation. In the second one, I'm going to add 2 to both sides, and I'm going to divide by 3, and there's another possible solution. Those aren't too bad, so I do think it would be possible for us to go back and run them through. Fractions can get a little messy, but doable, so if you want to. Otherwise, for checking on a test, you can just try and rework the problem, but don't look at what you've just done or you'll make the same mistake inevitably. You can't look at your own work and avoid it hardly. So I think that's all I've got for that one. Thanks for watching.